there's going to be many ways of doing these correctly. It kind of deviates from what you're used to, whereas this is the right answer, this is the right way. When we get to here, there's a couple ways that are equally correct. So if yours doesn't match exactly with somebody next to yours, it still could be correct, just in a different way. Don't sell yourself short. Check with me or other people and see if somebody else did it the same way you did. It still could be correct. Uh, Remember that these tasks, anytime you see a task, this is going to be a similar question that you're going to see on state testing. It's going to be one question with many parts trying to see if you know how to take everything you've learned and actually do something realistic. Many of you have always said, when are we going to use this in real life? This is a real life context, trying to come up with all the possibilities that you can get for $20. So this format is actually very important to learn, understand. And the part where they start asking you, hey, explain what this means, is very important. You're going to have to type out in words and explain in complete sentences what the slope means, what the y-intercept means. It's not just, oh, it means it's good or it's bad. Complete sentences, proper spelling, punctuation, capitalization, everything. It does count. All right, so that's the big picture. So let's just go through this and see how we do. Okay, so if you guys have answers, just go ahead and shout them out as I go over them. So if you bought only double doubles, nothing else, no fries, how many could you buy if you spent the entire $20? Okay, so you'd say 5 double doubles. And the way you get that is from, well, they're each $4. 5 of them would be 4 times 5, which takes up the whole $20, right? All right. And likewise with the fries, if you bought only fries, how many could you get then? If they cost $2 and you had to spend all 20, yeah, you get 10 fries. One thing we're not putting on here is that if we get 5 double doubles, it's assumed since we only bought double doubles, there are 0 fries, right? So this is like the coordinate, 5 double doubles, 0 fries. And this is how we make the link between this and the graph. There's two things. I have two axes. I have double doubles fries. I have a vertical, horizontal. Same thing over here. It's assumed since I only bought fries, that means I did not buy any double doubles. So 0, I'll abbreviate, double doubles, which would be the coordinate 0, comma 10. Notice how the order is important. Since up here I said 5 first, double doubles were first. Down here, double doubles have to be first, 0, comma 10. So that's the beginning of your table. Actually, it's the beginning and the end. These were called the intercepts because they have a 0 in them. So I know one of them is going to be on this axis, the vertical, and the other point is going to be on the horizontal. Now we want to find all the points in between. Now some would say go ahead and just do the graph first, and then we can make the table from that. I prefer to do the table and then make the graph. I mean, as long as all of it's finished at the end, nobody's going to know which order you went in, so whatever's good for you. And we'll use D and F. Of course, D stands for double double, right? And F stands for fries. And if you want to stick with the X and Y, the typical thing, that's fine. And just typically, whatever's on the left is the horizontal axis, and whatever's on the right-hand side is usually the vertical axis. So whatever you decide to pick for your letters, just try to put the horizontal here and the vertical here. All right, so we have 2 points. We have 5 double doubles, 0 fries, and I'm going to put the other intercept at the bottom. 0 double doubles, 10 fries. Reminder that both of these add up to $20. That's what all these have in common. I mean, these numbers are all changing, but what do they have in common? They all cost $20. So what are some other combinations of burgers and fries that cost $20? All right, go ahead and figure those out. What are all the other combinations that add up to $20? How'd that get there? Okay, so if you got 4 double doubles, that costs $16. How many fries can you afford? So 4 double doubles, $16. 2 orders of fries, $4. Yeah, so that's $20. Remember, they all have to add up to $20. If you got 3 double doubles, how many fries? 4. Now, at this point, can you see a pattern? Yeah, 5, 4, 3, 0, 2, 4. You can probably start making some predictions, and this is okay. And you can see, once we fill in the rest, I can be pretty sure that those add up to $20, but check them anyway. Does 1 double double, $4? Okay. 8 orders of fries, 16. 4 plus 16 again is 20. So yeah, that all works out. So, general rule, if you don't see a pattern in your table, you're not going to see a pattern on your graph. If you see a pattern here, like these are going down by 1 while these are going up by 2, and that happens every single point, you probably have a good graph to work with. So let's do this. Do you want to put the double doubles on the vertical or the horizontal? Well, probably on the horizontal just because we have them on the left. So go ahead and label it. Okay. And then fries will be on the vertical. Okay, so for double doubles, I only have from 0 to 5. My minimum is 0, my maximum is 5. So one thing you'll have to decide on is, should I do this? So I just count by 1, 1, 2, 3, 4, 5. You'll notice if you do that, you only use like this tiny little piece of the graph. So, and you can see that, well, if I made it twice as big, it might go out to here and use more of the graph. So whenever possible, use more of the graph. So I'm going to count every 2 squares as a double-double, just so I use more of the graph because the graph will be bigger, easier to read. Now, if you didn't do that, would it be wrong? No, but it wouldn't look as good as it possibly could. If you try this with the fries, if you start counting, it'll be 1, 2, 3, 4, 5, 6, 7. You wouldn't be able to get to 10. So on this axis, you can't count by 2 squares. You have to count every one. So it'll be 1, 2. So, and it's okay that they're different. Some might say, well, this is counting this by 2 squares. This is counting by 1. That's okay. That's perfectly fine. And you can also count by, I mean, if we were going up to like 20, we'd have to count by 2, 4, 6, and so on. So you can change that as well. So from here, just graph what we have. Our 2 intercepts. Where is 5, 0? So here's 5, 0. Where's 0, 10? 0, 10. Okay. 4, 2. There, 4, 2. 3, 4. 3, 4, 2, 6. And you, just like we did before, you can kind of see the pattern. We saw the pattern up to here, and we're able to get these 2 just by finishing the pattern. We could do the same thing here. Just keep following the pattern and get the next 2. And sure enough, they all match up. Just like here, when we finished here, we went down 2, 1, it matched up with 0. We counted up 2, 4, 6, 8, it matched up with 10. So you notice how we're doing the same thing, one time on a table, one time on a graph. All right, good sign. Now, any questions or clarifications up to this point? You should have a graph that looks like this, very similar. It is possible if you switched and put the fries down here and the double doubles up here, that's fine. So your graph might look different. You might have 0 to 5 on here and 0 to 10 down here. Your graph will look different, but it'll still be going through the same points. It'll still line up in a straight line. That was one of those things I was mentioning earlier. You could do a different way and get the same, still be correct. All right. Next thing. Should we connect this line? Should I just draw a line right through it? Why or why not? All right. So if I draw a line and I say, let's see here, look at this point right here. What is this point right here? It would be 2.5, 2.5, comma 5. Now, here's what's different from what we've been doing. What does 2.5 stand for in this problem? So 2.5 is right here on this axis. What's on this axis? All right, this stands for 2.5 double doubles. All right, can you order, go to In-N-Out and order, I want 2.5 double doubles? Can't do it.
Yeah, you get 3 by 3.
And the question was, can you order 2.5? Right, answer to that would be no. So this is impossible. Same thing right here. If I just take this random point, this is like, 1.75 comma 6.5. Right? Is it possible to order 1.75 double doubles and 6.5 fries? No. So all these fractions that are on this line do not exist in real life. So we cannot include them on our graph because they don't really exist. This is not the case on every problem, though. If we're talking about gallons of gas and how much it costs, you can easily buy 6.125 gallons. That's reality. You can do that. But with burgers and fries, you can't. So it's a problem-by-problem decision you have to make. So while these do line up in a straight line, we don't really want to connect them, but you want to imagine there is an imaginary line that does connect them, because after all, there is a nice pattern. We saw it right here. These go down by 1 while these go up by 2. So it's not as if there's no pattern, it's just that there's no realistic meaning to some of these points on a straight line. Okay? All right, so that's kind of like phase 1. Phase 1 is just get the graph, get the table. Phase 2 is actually write the equation and talk about all the parts of the equation. So you guys know from your test yesterday, this is all y equals mx plus b. Whenever they're asking for a linear equation, they're asking for a slope-intercept. That's what we practiced. So we also practiced the first 4 questions or 3 questions on your test where here's the graph, what's the equation? So by looking at this graph, what is the equation of it? Okay. So what is the slope? What is the y-intercept, right? And that's what all these questions ask. So what is the y-intercept? Let's start there. Where does this line cross the y-axis? At 10. So the y-intercept is 10. That's actually the answer for D. B equals 10. Just like you did before, you're just seeing where it crosses the vertical axis. What is the slope? Is it positive or negative?
Negative.
Negative's going down. Now be careful here. Watch this. It goes down 2 squares and it goes right 2 squares. However, remember over here we're counting by ones. Over here we're not counting by ones, right? So you have to look at the scale. So we're going from 8 to 6. That's down 2. Right here we're going from 1 to 2. How far is it from 1 to 2? It's only one. So when you're using different scales, you have to look at the scales when you're counting. What you don't want to do is count squares, saying it's down 2 squares, right 2 squares. So be very careful there. So as I mentioned before, going down 2 and right 1. Down 2, right 1. My slope is -2. That makes my equation y equals m -2x plus 10.
That's different if you put inverters.
Yes, if you flipped it, your y-intercept will be 5, and your slope will be -1/2. Yeah. So if you did it the other way, you might have -1/2 and +5. So those would both be correct. Now, here's the grand finale. Assume everything else was worth 1 point and C and D are worth 50 points each. This is where we really want to put all our focus and attention in. What do these things actually mean? This is the important part. So what does a slope of -2 over 1 actually mean? And if they're asking for meaning, here's a good hint. Include units. It's -2 what? Go back up here. We went down 2 on the vertical axis. What is the vertical axis? It's fries. So when we say we went down 2, they're talking about we went down 2 orders of fries. And if we went right 1 what? Well, the right and left is double doubles. So that we went from 1 double double to 2 double doubles. So the bottom here is going to be double double. I'm going to put DD apostrophe S for double doubles. So what does this mean? My slope? For every 2 order of fries I don't get, I can buy 1 more double double. Does that make sense financially? 2 order of fries cost $4, and 1 double double costs $4. So it makes sense that for every 2 fewer orders of fries, I'd save $4. Therefore, I could now buy 1 more double double that costs $4. So the top and bottom are equal to each other. Okay? Top and bottom are equal. All right, so now we want to write that out in words. And this part you can do many ways. For every 2 orders of fries, or every 2 fries, for every 2 fries, let's see here, how do we say that? Every 2 fries, take off the order okay, I can get 1 more double double. Something to that effect that shows you understand that 2 orders of fries is the same as 1 double double. So if I take off 2 orders of fries, I can get 1 more double double. There's probably a better way to say this and phrase this, but try to come up with it. What does the y-intercept mean? Again, what does this 10 mean? You might go back to your table. You know, well, 10, y-intercept of 10 is 0, 10. And really, if you go way up here, that's where it all started. Well, that's if you only bought fries. If you only bought fries, you can afford 10 orders, and that costs $20. So some of these questions are, well, come up with it. Others are just kind of look back. It's like summarizing. You already did the work, just kind of summarize it in a sentence. Okay? So what does y-intercept mean? Okay. Y-intercept, and you can say, start off with y-intercept means how many fries could I get? And I'm basically paraphrasing number 2. How many orders of fries could I get if I didn't get double doubles? I can get 10 order fries, $2 each, cost 20 bucks. That's what the y-intercept means. If you did the graph differently, you'd be talking about I can get 5 double doubles for 20 bucks, but no fries. So again, there are two very similar answers here that are both correct. Okay. So that's the money right there. Right here is the best piece of information I can give you using the units. Okay. Even the y-intercept, we use fries because the units of the y-axis is fries. So when you're asked to explain something, and this is true even in science, when you're graphing, all different things in science, and you always use units. They're usually centimeters and things like that, but it's the same rules. When you explain yourself, include units. All right, now I mentioned before, you could probably answer these questions on the back without the graph, but now with the graph, it's just a little bit easier. If you buy one double-double, how many fries could you buy? And if you look at it, okay, one double-double, I can get 8 orders of fries. I don't have to do any calculation. I know one double-double gets me 8 orders of fries just by using a graph. Okay, so write that out. Okay, I could buy 8 orders of fries. Remember, complete sentences, punctuation, capitalization do count, spelling does count. There's no such thing as, well, do I have to spell correctly because I'm not in an English class? You have to spell correctly 24/7, 365, all the time, everywhere you go. There's no on-off switch with spelling, and just always do it. Do you have enough money to buy 3 double-doubles and 3 fries? Okay, let's look at the graph and confirm. Can I buy 3 double-doubles? There's 3 double-doubles. Yes, 3 fries. So you notice that all of these are $20, and since this dot is below the $20 line, I can afford it because it's less than $20. So just on the graph, I don't have to calculate anything. I already know that it will. Okay, so yes. And you can also give a calculation here. 3 double-doubles will, at $4 a piece, cost $12. 3 fries at $2 a piece cost $6. So yeah, it only costs $18. But the purpose of all of this is to not have to do this part. It's to be able to just look at the graph and see, yeah, 3 double-doubles, 3 fries, it's below $20. It's below the line. They're not asking you how much does it cost. They didn't want you to come up with 18. They're saying yes or no, can you afford it? So yes, we can. And just keep on going. Do you have enough money to buy 4 double-doubles and 4 fries? All right, use the graph. 4 double-doubles right here, 4 fries right here. It's above the $20 line, so you know that that's more than $20. go ahead and explain that in the same way. No. The coordinate. By the way, if you're not writing this part down and you're just saying, no, it costs $18 and that's why not, I just got finished saying that's not what they're looking for, right? They're looking for this. So take good advice when you see it. This is what we're looking for. What happens is we're going to come across much more complicated problems. You're not going to want to go through all the calculation. What if there's 5 different things? That's too much work. I can look at a graph. It's about using the graph. It's a much faster way than trying to recalculate everything. Okay? The coordinate is above. And above means more expensive. Yeah. Oh, more expensive. Over budget's fine, yeah, that's fine. You can think of, that's a very good actually word to use. Think of this as your budget line. Anything over will be above it. So if you got any combination, 4 double doubles, 7 fries, that's above the line. That's over $20. That's over budget. And of course, the last question is, well, assuming you could spend $20, not exactly, but anything less than $20. Let's say if you want 1 burger, 1 fry. They want you to graph all the possibilities of double doubles and fries. What are they? That don't cost that cost $20 or less. Okay, so that would be every single point here. 1 double double, 1 fry. 1 double double. See, these are all underneath the budget line. So I know all these without having to recalculate and see how much they cost. Since they're physically, visually beneath the line, I know I can all afford these. 2 double doubles, 2 fries, 3 fries, 4 fries, 5 fries. I can afford all those because they're below the line. So these are all the possible combinations that I can afford right here. And it's kind of the pain to have to write out all of them, but visually it's just a dot. So it's much easier just to use the graph. Before, we could say it's kind of like shading. It's kind of like everything below the line. But remember, it's not shading because right here is not a possibility. I can't do half a double double and 2.5 fries. So I don't want to shade it. But I just want to know that I want you guys to show that all these are possibilities. They're all $20 or less. Okay. And how would you describe all these? Okay. Something to that effect. How do you know those all cost less than $20? I didn't do any calculations. I didn't have to find out how much 3 double doubles and 2 fries cost. How do you know? They're below the $20 line. I don't have to. If they're asking how much they all cost, sure, I have to go through all that, but it's just about coming up with all the possibilities, but without actually calculating it all out. Okay? So that's all one problem. The words will change. The units will change for the next problem. Try not to make this a carbon copy for your homework. It will be similar. Don't just copy it, say, well, it's all below the $20 line. Well, maybe on the next one it's not going to be $20. It's going to be something else. You have to adjust. Okay?